Hi, I'm Vincent Ott. I'm part of the JASP team, and today I will show you how to create Raincloud plots in JASP. Throughout this video, I will refer to some datasets and resources and links to websites, and you can find all of that also in the description of this video. If you use the Raincloud Plots module in JASP, please consider citing us. How you can do that is also explained in the video description. Before we now get started and get plotting in JASP, I would like to give you two quick reasons why you should start Raincloud plotting in the first place. The first reason is this Raincloud quartet that we created to illustrate the usefulness of Raincloud plots. You can see that we have 4 different datasets for different distributions, and we can see their means and their confidence intervals. And clearly the means and the confidence intervals are identical for these 4 datasets. But you can also already see from the description, from the legend on the right hand side, that apparently they seem to be different. There's a normal distribution, a bimodal distribution, and 2 more. And to explore what's up with these 4 distributions, I will now show you Raincloud plots for these 4 distributions. So I'll give you a second to just look at it. On a macroscopic level, you can already see that there, seem to be 4 clouds, right? We have the raw data points, which are kind of raining from the box plot and the probability density function above. And together, each of these 3 elements, the raw data points, the box plot, and the density function, they together make up a Raincloud plot. And yeah, now we can immediately see that the 4 datasets are completely different. For example, we can now clearly see there's a normal distribution and a bimodal one, also a skewed distribution, and one with outliers. And these striking differences are something you would completely miss if you just consider the identical means and confidence intervals. The second reason why you should use Raincloud plots, I will illustrate with some real-world data on penguins. And you can see here there are 3 different islands where penguins live on, and we can also now see the bill lengths for these penguins. And apparently on the first 2 islands, the bills seem to be longer than on the 3rd island, as shown by the means and the respective confidence intervals. But now, if we look at the Raincloud plot for these data, then you can immediately see 2 things. First of all, the individual data points, they stretch much further than the means themselves, right? So there are clearly also several penguins on each island who are much further away from the means than other data points. And the other thing you can see is on the 2nd island, the Dream Island, there seems to be some sort of clustering, right? So on the at the top there seem to be some data points, and they correspond to to one mode in the density function. But then also at the bottom there also is some clustering, and this corresponds with another mode of this bimodal density function. And now when you look at this data, you might ask yourself, okay, what's going on here? How could we explore this further? And fortunately, the data set also contains the information of penguin species. So if we now also consider that, we suddenly find that there are 2 different species living on Biscoe Island and Dream Island, but there's only 1 species living on the 3rd island. And yeah, this is also something, if you again consider the plot in the very top left with just the means and the confidence intervals, this is all kind of critical information and important information that you would miss if you don't use Raincloud plots. Now I would like to give you some preview of the plots that we will create today. These are not all plots, but some of them. And you can already see there's some sort of neat, tidy plot in the top left, which might be something for a thesis or a publication, but then you can also see individual trajectories, covariates, and for data exploration, and then also something with a bit more complicated, but it only looks more complicated. It's very easy to create. We can also see a 2x2 design. And in case you don't have JASP installed yet, you can just go to jasp.org/download and you can get it for free, no strings attached, for Windows, for Mac, and also for Linux. And now, after the cut, I will see you in JASP and we will get started with plotting. Okay, we're now in JASP and I have already imported the dataset that we will be working with. You can see that it consists of a dependent variable, a covariate, a condition, so the condition in which each observation was observed in, and then also an ID, so a unique identifier for each observation. And then to the very left over here, this column just states the row number and it's not relevant for plotting. One important thing about the structure of this dataset is that it is in long format. So we have the dependent variable in condition A, also in condition A, and so forth as we go on. But at some point, we then get the dependent variable in condition B, and then later on even condition C. And this is in contrast to what would also be possible. It's called wide data format. And then you would have, for example, the dependent variable as observed in condition A. And then another column for the dependent variable as observed in condition B. And then another one for the dependent variable as observed in condition C. And what then would be also missing is this condition column over here, because it would be encoded in the three columns with the dependent variable for each condition. It is important for the Raincloud plotting in JASP that your data is in long format, so the way it is right now. If you have data in wide format, you would first have to transform it. To do that, you can do so in a few clicks via a nice website that was created by Luke Korthals, and the website is called Shiny Data Witch. And the link to this website that lets you transform your data easily from wide format into long format is linked in the description of this video. Now, let's go to the Raincloud Plots module in JASP. To do that, we just go to the descriptives over here, and then you can already see that second from the top, we have the Raincloud Plots. And when you open the module, you can see kind of three sections. On the right over here, we can see the Raincloud plot. It's currently empty because we haven't started creating it yet, but this is where it will show your Raincloud plot as you go on plotting. Then to the left over here, you can see the variable selection. So basically, here you select the variables from your data set that you want to plot. And then lastly, at the bottom over here, you can see different sections with different settings. And I will explain them throughout this video. And lastly, again, the note that your data should be in long or must be in long format for this module. If you have any questions on specific settings and how they work, you can also click this button over here. Then you will get to the info for this analysis, and then you can see all the different things that you could do to alter and edit your Raincloud plot. Okay. For the first plot, let's just consider the dependent variable in our dataset. So we select it as dependent variable. Then you will find that on the right hand side we now have a plot of our dependent variable, and we can see that it is ranging from about 0.2 to about 0.8. At this point in the video, it's now worth to note that we created this data set for the purpose of showcasing the Raincloud Plots module. So the name is very generic. It's just a dependent variable. In your case, you might probably have a more informative name. We just chose the name so that it's easy to follow along when you're creating your own plot. I will later also show you how you can change the axis title, but we will leave it as is for now. As for the general settings, you will find that you have different options to color your plot. For example, right now we have one colorblind friendly palette. There's also another one, for example, this one. And then also a bunch of others. You can also choose to disable the coloring like this, and then you just get a black and white Raincloud plot. And then last, we also have the option to make a horizontal plot like this. But for now, let's go back to vertical. You can see that there's also the option to do to inspect statistics of this Raincloud. So now if we click this option, we will find that we have 150 observations in our dataset, and overall we have, for example, a median of 0.56. You can also see that there's currently no primary factor. Well, this is because we're just considering the dependent variable without the condition over here. But we can now also inspect this condition by simply selecting it as a primary factor. And suddenly we have some additional split on the x-axis. So now we have condition A, B, and C. And let's just take a second and let's just look at what we have in front of us. So we can see 3 different Raincloud plots for each condition. We can also see in the table below that we now have the primary factor, right? So the condition, which splits up into the 3 levels. And apparently for each condition, we have 50 observations. What we can find also from looking at our Raincloud plots is that condition A and B seem to be relatively comparable, at least when we look at the median, right, the central tendency. But condition C seems to be a bit higher with 0.58. And in fact, the way it is with the simulated data set, there's extreme evidence that condition affects the dependent variable, and so that if you were to compare both with a frequentist or a Bayesian ANOVA, or then also follow-up t-tests, you would find that A and B are comparable, whereas C is greater in the dependent variable than condition A and B. Okay, now that we have got this covered, let's take a look back to our color settings, right? Because we have disabled it in the previous step, but we can now reapply the coloring, and then we will find that there are also now nicely colored clouds. For example, we can also go back to the previous colorblind setting. If you want to, there's also the option to show a legend. Of course, you already have conditions A, B, and C stated here on the x-axis, but if you wanted to, you could also have it say here as an additional legend. And depending on your use case, it might also make sense to use the legend and then, for example, not use the x-axis, or like crop the plot accordingly. I will also later on show you how you can edit your plot further. This plot right here consists of 3 clouds, but yours might have 4 clouds because your primary factor, here the primary factor is condition, but your primary factor might have not just 3 levels but 4, or you might only work with 2 levels for your factor. And so essentially in every plot that you will create, the amount of elements will differ. For example, right now also we have 50 observations, so 50 points per condition. All of this might vary. And so it can be very useful to fine-tune the elements of your plot so that it looks tidy and coherent. And for this, we can make use of the Cloud Elements settings. And these offer a bunch of ways to alter the plot. For example, we can change the position of each element, right? For example, right now the nudge of the violin is 0.15, but we can also slightly increase it, and you will see that it will move the violins further away from the boxes, which are nicely placed over the ticks. And this is also why the box nudge is at 0. Similarly, we can also, for example, change the spacing of the points, so we can move them also further away. And now that we've created more space between our elements, we could also now make our boxes a bit wider if we wanted to. Also, we could change the spread of our points, right? So now they jitter a bit further and they are easier to spot now. And relatedly, we could also alter the height of our violins. So for example, like this. Now they're slightly higher. I'm not sure if you caught that, but we could also put it to 1. And since they now start to reach into the other into the points of the other clouds, we could also actually decrease the nudge again. So basically the takeaway here is that you can edit a lot of the cloud elements. I now made a cut to show you 2 scenarios in which it might make sense to basically fine-tune the elements of your plot. Consider that you don't have 50 observations per condition, but let's say 200, right? Then with this current spread, this might be a bit tight and squished together, so maybe you would want to increase the spread of the points. Similarly, because you have so many points overlapping, maybe you would also want to decrease the opacity of the individual points, so like so. Then each point individually won't be as salient, but for example, if they're now really overlapping, so like so, right? Because now you have to consider if you have many observations, then you will have some points over here and also over here, and now just decrease the spread to showcase this in this example. You will still find that with an opacity of 20%, at those positions where many points overlap, right, where there's some clustering, you will still find darker shades of the points. Also, the second scenario in which it might make sense to fine-tune the elements is that from time to time I also see Raincloud plots that are a bit more compact and don't take up as much space. And what people do is they kind of place the boxes inside of the violins, or in our case now we would place the violins behind our boxes. And to do that, we can first change the nudge of the violins, like so. Now you will find that they are placed behind the boxes. And then, that we are still able to see the boxes, we could change the outline to black and also decrease their filling, their opacity to 0. So now we have the boxes, which are kind of clear to be seen over here. And then we can also remove the outline of the violins, like so. And now the violins themselves, they're still there, but they don't kind of distract as much attention from the boxes, right? So now you have kind of a bit more of a compact plot that doesn't take up that much space. At this point, we now have an idea of what our data looks like, and we also have an idea of what's possible with the Raincloud Plots module in JASP. So let's now try and create a tidy plot, or even 2 tidy plots that we might want to use for a thesis or a publication. And for this, we can create a new plot from scratch. So basically, we just go to descriptives again and select a new Raincloud Plots, which will give us another section. Right now we have this empty plot over here and our previous plot over here. And what you can see is that currently both plots, or both sections right here, they share the same name. And this is a bit unfortunate right now because you might know what the individual sections contain, but if someone reviews your work, so for example, if your supervisor looks at what you've done for your thesis, or if you want to submit this to a journal and then your reviewers look into your analyses, then they might not necessarily have an idea of what you've done here, right? So in these cases, it can be very helpful to rename these sections so everything is tidy and easy to understand for other people. And to do that, you can simply click here to rename or edit this title, and we could call this here Exploration. And this one over here could be, for example, the comparison of means, because that's what we're going to do now. And for that, we select the dependent variable again, we select the condition as primary factor, and then also we remove the coloring, because usually if you don't necessarily need color, then it can be also a good idea to not use it. Like so. And let's also say we are for now fine with the cloud elements. So we don't edit anything over here, but we go to the next section. Yes. Let's say our dependent variable in this specific use case is accuracy. And then accuracy does not only range from 0.2 to 0.8, but it would maybe reach from 0 to 1, right? An accuracy from 0 up to 100%. And for this, we could also change the limits of our axis. So if I now click this, it will look a bit weird for a second because the default setting is that it jumps to 1,000. But if we now set it to 1, then you will find it goes from 0 to 1. And yeah, depending on the use case, you might now want to change well, your axis limits. And this option makes it possible. And then you can decide whether you want to do that or don't want to do that. Yes, and you can also now, for the sake of reproducibility, also change the dimensions of your plot. So for example, you can make it a bit wider if you want to, but maybe that's a bit too wide. Let's keep it like that, and maybe we can also make it a bit higher. And you can also do this with the mouse, like so. But there are two problems with this. One is, as we change our plot, the dimensions will also change, and they will also always change to these dimensions over here. So for the sake of reproducibility, it's best to always change the plot size via these two options and to not do it with the mouse. Because right now, it will at some point will jump back to what you've specified over here. So that's your safe bet. And what this option is, show caption, I will show you in a second. It will become apparent when we look at the means. And to look at the means of our data set, we can simply go to the advanced section and select mean. And it currently says the position is custom. And this by default just means it is placed on top of the boxes. So for now the size is maybe a bit large. We can maybe make it smaller, so we can see the diamonds inside the box, and also what becomes apparent already from the densities, right? The violence over here, that this distribution seems to be a bit skewed, right? The mean and the median, the stripe over here and the mean are a bit displaced, and here they are more on top of each other. Yes, we can now also say let's disable the custom limits again to get an even better idea and to zoom in. And like I said in the previous section on the cloud elements, right now we have this specific plot. It might now make sense to make the boxes a bit wider, right? So that the means are easier to spot, because now we can also increase the mean size a bit, say maybe to 6. And now each, or even 7, and now each mean and also each median is easy to spot, right? Okay. Now, let's say you also wanted to do inference and compare the means, right? Then you have two options. I would say right now you could already finish up this plot as is and put it in your manuscript. But you could also say, hey, I want to connect the means like so. Then we can already see the trend, or basically the difference, that there isn't much between conditions A and B, but there's more so of a difference to condition C. And going even further, you could decide to show confidence intervals around the means instead of the boxes. And I would say it's just important to be conscious about it and make a conscious decision, because you could now argue in two ways. One is, this is the data and how it looks like in your data set, and then this is what you also visualize in your manuscript or in your presentation. And then additionally, as you do the inference and run, for example, a frequentist or a Bayesian ANOVA, you can then also report confidence intervals, for example, or credible intervals in your manuscript, but then kind of you have the data as is and your inference in the text. That's one option, to be very descriptive about your data and kind of separate it from your modeling and your inference. But if you also want to visualize the inference, then you might very well argue, hey, let's look at the confidence intervals and how they differ between conditions. And for that, we can simply click this box over here, which will make the box plots disappear and show confidence intervals around the means instead, like so. And just what I wanted to say, right? You can either now try and export this plot to your manuscript. I will show you in a second how. Or you can opt for the more inference-heavy visualization and export this plot. What's kind of important and nice to have is that you now also have this info over here, that the intervals around the mean represent confidence intervals. But then as you export the plot, maybe you would want to get the full possible space available for your plot and store this information over here in your figure note within your manuscript. So before you export the plot, you could then also remove the caption like so, and now we have more space, right? And not this caption over here. You would just have to remember yourself to later on also report it to your audience. Okay, so now, like I said, we can either maybe export this plot or also export this plot. And to do that, we do a last final step of fine-tuning. And for this, we are going to edit our image over here. And then you will find that we now have the option to change this axis and then also this axis over here. And I will walk you through it. So for example, let's pick something more informative. Let's say we have not a condition, but say an experimental manipulation, just for the sake of demonstration. And then also we would not have a dependent variable, right? Because I just said we have accuracy in this specific scenario. And then, we could also now fine tune this again, right? We could say it ranges from 0 to 0.8 or to, or to 1. And then this, of course, again, alters the dimensions a bit, right? So then it might be more useful to do what I showed you before outside of this last step of editing, where you kind of change the limits beforehand, right? So you go over here, and then you kind of maybe decrease the size of the means again, maybe like so. And then only then you go into this editing step, where you manipulation, and then also, well, do the titles again, accuracy, and Now you have it from 0 to 1, right? You have the 3 means and conditions, and you have these steps over here. And the last thing is to just manually set the ticks, which can be very useful because, for example, if you have a psychology background, then usually APA style says if you have values that can only range from 0 to 1, you would omit leading zeros. So for example, in this specific use case with accuracy, you would have a label of 0, and then 0.2 instead of 0.2, and then also do the same over here. Over here. And lastly, we just have a 1 up top. Okay. And with that, you could now save the image as a PDF or a PNG file and then import it to, say, your manuscript. Now we currently have the confidence intervals enabled. And if we now again enable also the table with the statistics, we will now also find that we not only get the observations per group, but also the box statistics, and then also the mean and the lower and upper bounds for the confidence interval, right? And to make it a bit easier to inspect, we can also disable the box plot statistics like so. In the current example, condition C is at around, right, 0.6. And it's not up here at 0.8. And so right now, it's difficult to evaluate how much is this slope, is this increase, right? We already I told you that the conditions are simulated to differ, both if you do a frequentist and a Bayesian analysis, but well, how much do they differ? How big is this effect? And to get a better idea of the effect, we can also visualize the data differently. And to do that, let's make a new plot, like so, right? And now we had the exploration, we have the comparison of means. And now, well, we will do another comparison of means, but let's look more at the effect size in detail. And to this end, we again select the dependent variable, but we will now do something different with the condition. We won't use it as primary factor, but we will use it as secondary factor. And this will create a split of Rainclouds, not via the x-axis. So this is what we had previously, right? And then we chose to disable the coloring. But we can also make this split as a secondary factor, and then it will be color-coded, and then we also cannot disable the coloring. So you will now find that the Rainclouds are overlapping, right? We can compare the boxes, the densities or the violence, and also the points, although they seem to be scattered. So, like I said before, we can now also select a different color palette, and you could also now choose to maybe select something that's a bit easier to spot and understand, because right now, we have the focus on the dark cloud, which is condition C, which seem to differ more than the other two. Let's also do it horizontally. And let's again consider the means. So we would do this down here. Just before, we considered confidence intervals. But it is also possible to use a Bayesian approach. And then you can also visualize your credible intervals for the means. Now, if you are not familiar with Bayesian statistics, you can just follow along for the rest of what I'm going to explain, and just again use the confidence intervals. But for anyone curious about the Bayesian approach, it would be as follows. Basically, we choose to apply custom mean intervals, so custom intervals around means. And for that, we first have to identify how many clouds are shown. Right now, we are seeing 3 clouds. And then what we would do is we specify for each cloud, so A, B, and C. We specify the lower and the upper limit. And if you run a Bayesian ANOVA, then you would find that for one cloud, it's 0.55 as a lower limit. The upper limit should be 0.6. So I just did this now for the sake. Oh, sorry, I also have to enable the custom interval limits like so. And yeah, there's sometimes a bit, it's a bit tricky. You can now see that I kind of misspecified the custom interval because cloud ABC, this does not correspond to the condition levels, but this is merely just the labeling for each individual cloud. So as it turns out, what I would now have to do is I basically take the 0.55 over here and then the 0.62 over here, and this would go back to 0. And now we have the first credible interval. I'm sorry if I previously said confidence interval, right? Because right now we're specifying Bayesian credible intervals. And then we would do the same for the middle cloud, which is 0.4 and 0.55, if I'm not mistaken. And then also 0.48 and 0.55. So now we have the credible intervals defined. And also, we now see that the interval around the mean is custom, right? So again, when you later on export this and then would want to write, hey, I'm using credible intervals here, then maybe you would want to disable the caption. Also, I now notice in this specific use case, maybe let's use another color palette because maybe that's easier to spot then. And what we now have is the gray cloud for condition C, and then also, well, conditions B and A. Another thing I just noticed is that maybe we would want to change the order. So basically, maybe we would want to have A on top, then B, and then C. And this is also possible. Just bear with me. I will show you how to do this. For that, we can edit the data over here. So we go to condition, and we can see the different levels of our factor. And then here's an option to reverse the order of all labels. So I just did that. And if we now go back to our plot, you will find that we now have condition A on top, then B, and then C. Of course, now, unfortunately, the custom intervals don't match. So now we would have to redo that. So now it's 0.55 and 0.62. And then I think the middle is still correct. And then we can do this. All right. And maybe also to highlight the groups a bit more so that they're easier to discriminate, we can now also maybe edit the cloud elements again a bit. So maybe we make the violence a bit bigger, like so. And now we can see it slightly cut off. So let's also increase the size of our plot a bit and also decrease the nudge, maybe like so. Yeah, you now can really see how it's all coming together because you kind of have to fine-tune each plot for the specific use case. So let's fix this. Maybe we decrease the nudge even further. That looks good. So the next step would be maybe to change the nudge of the means so they don't inside the violence. So we could do something like if we now do 0.1, they will move up, I think. Yes, so we now do a negative value of maybe 0.5, but that might be too much. Yeah. Let's go with 0.2. Oh, I'm sorry. Yeah, this is always a bit of fine-tuning that you have to do, but that's also a good thing about the module, right? Because you can create a lot of plots for a lot of different scenarios. So please stay patient while I fine-tune the plot a bit more. Now we're kind of able to also interpret this effect, right? Because you now know that the confidence intervals don't really overlap. Sorry, the credible intervals in this specific scenario, right? But if we now check the confidence intervals, they don't overlap, right? But in any case, you would now want to discuss your effect size. And I know that there are guidelines to interpret effect sizes, and we can quickly look into that. But for now, I just wanted to ask you, what do you think? Is this a large effect? Is this a medium effect? Is this a small effect? And you might probably say, well, first of all, it depends on the context, right? We don't know what this dependent variable means right now. What was our experimental manipulation? What would we expect beforehand? And we can kind of see that the green cloud, so for condition C, is moved a bit to the right. So there's some sort of shift. But yeah, how big is this effect? That's now something that you would have to discuss. As a measure of effect size, let's now look at cohens D. And for that, we can just eyeball it for now. We don't need the exact value. And we can go to the descriptive statistics over here. And if we now select the dependent variable and also split by condition, then we will find the free means, right? And it's the mean of condition C seems to be greater than in the other two conditions. And also the standard deviations of all three conditions seem to be roughly the same. So we can already kind of eyeball. Maybe we can also do it like this. We can already kind of eyeball that cohens D is around 0.8 or even 1, right? Because condition C seems to be almost, the mean of condition C seems to be almost one full standard deviation larger than the other two conditions. So just very roughly and eyeballing it, this seems to be a large effect. And I just quickly wanted to show you that because as a closing thought or a closing question, I would now just ask you what you're seeing right here. Would you personally say this is a large effect? And yeah, Raincloud plots now allow to discuss this. The data set also contains a covariate, so let's explore this. For that, we again create a new cloud, a new Raincloud plot. And we again simply select the dependent variable. And we can maybe again split by condition. Let's also remove the color. And basically the only step that is now left to do, we take the covariate and select it as a covariate over here. And let's make the plot a bit wider. And what we then find, apparently, is that you can here see the legend of the covariate. And apparently in condition C, the values of the covariate are much lower than in the other two conditions. That's the first thing that's notable. And this basically also kind of now raises the question of, okay, is maybe this difference in the dependent variable, is it really due to, for example, the the difference in condition because of maybe the experimental manipulation in condition C? Or do we have a confounding factor here due to the covariate? And this is now something you would have to, or could now also further explore by looking into the data that you collected, considering your experimental design again, for example. And this is now possible to see, right? Not only do we get the distributions for each condition, but we also now have the option to inspect the covariate. And there's a second thing that we also now can investigate. For example, we can check within each condition how much variance is there regarding the covariate. For example, if we consider the few outliers in condition A, in B, and also in condition C, then we can see that they all kind of have a similar value as the other points in the group. So the outliers do not seem to differ with regard to the covariate within their own group. But of course, this is something we did not know before, and this might be different in your case, right? And then you might do further inspections of the outlier observations. Also, right now we have the conditions in reverse, right? C, B, and A. And this is because of the change that we made previously when we were looking at the effect size. And so what we can do again is just reverse the labels like so. And now the order is reinstated. And of course, this also implies, should you, if you might want to use it in your specific case, we could also say, hey, condition B is now at the first spot, and then A, and then C. Up until now, we have treated the condition factor as if it were a between participant factor. So there are 50 observations in condition B, for example, and then another different 50 observations in condition A. And so this also means that when we previously looked at the confidence intervals that you can calculate down here, right? If you click the mean and then the interval as a confidence interval, all of these were also calculated accordingly, basically considering condition as a between participant factor. However, you might also have additional information, right? Because previously, before I continue with my thought, let's reinstate the order. So let's put condition C back between the other two. So now we have A, B, and C. And now we can also close this window again. Okay, if you recall, we also have this ID variable. And essentially, there are actually 50 participants. So we have IDs from 1 to 50, and they were observed in condition A, but then also in condition B and also in condition C. So actually what we could also do now is consider this as a repeated measures design and also visualize this accordingly. And up until now, like I said, we treated this as a between participant factor. This was not a problem, right? The plotting and what I said still holds. It just now kind of, I offer you the additional option to also visualize repeated measures designs. And to do that, we can create a new plot. And then we again select the dependent variable. We select the condition. And now what we do is we select ID as our kind of unique identifier for each participant and, well, select it as an ID. And you already see there's something happening here, but first of all, let's just make the plot a bit easier to look at and tidy it up a bit. So we will go to the advanced section and we will now select custom colors, which For that, we again select that we have three clouds over here, and then we select custom colors. And you now can already see that's the default color, but actually we can also make use of a nice color palette. It's called the IBM Colorblind Save palette. And then we take this code over here, because we already kind of know, right, that A and B don't differ that much. And then there's also condition C, which seems to be a bit different, like so. All right, so that's kind of our first step to, first of all, kind of make it easier to see what's going on here. The next thing that we can do is also we can apply custom orientation for each cloud. So right now, all the violins or the densities are to the right of the plot. But we can also decide that we want some of them plotted to the left. So basically we now mirror some of our plots. And to do that, we can apply custom orientation like so. And you can already see over here that the default orientation is that the violins are facing to the right-hand side. And so when we now click this, one thing is happening, that the points are now centered over the axis ticks. This is something that is now becomes mandatory with the custom orientation. You can see how this changes. And then the second thing that now becomes possible is we can put the L as an orientation for the two groups, like so. And maybe as a last step, we can remove the outline from the violins, so that the focus is more so on the individual points rather than at the other things. So now we kind of focus on the individual trajectories. Maybe we can also increase the width and the height again, like so. And yeah, of course, you could now fine-tune this even further, but I will leave it as is for now to just show you what I wanted to show you. Basically, the individual participants do not seem to differ that much between condition A and B, but then they seem to all move upwards for condition C. So kind of the general effect on a group level seems to hold from condition for basically all participants. But, and here's the huge but. Apparently, there are some participants who, let me try and zoom in, who apparently do not have a change, like no change at all from condition A to condition B. And then even more important, they also don't change from condition B to condition C. And if I recall correctly, we simulated something like 15 or 20 participants that show this pattern, right? We could even now try and count this. We could maybe increase the spread of the points a bit, like so. And then we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe 13, 14. So something like that. The exact number is not important, but basically there's a substantial share of participants or observations that does not differ between the conditions at all. And well, what's up with that, right? And we now don't know for sure, like we don't know what happened here, but now we know that it kind of happened, and this is what our data looks like. And circling back to the very beginning of this section of the tutorial, I mentioned confidence intervals. Now that we have this information about the ID, and that this is in fact a repeated measures design, JASP now also knows how to correctly calculate the corresponding confidence intervals. So now let's make the plot less cluttered for that. So we remove all this custom information. We also remove the color. oh, I'm sorry. Now we also do the, well, color palette or black outline like this. So now, say we wanted to look at the means, then we can also do that, right? They're shown right here. And then we can calculate also the interval around the mean. And now it will also match the repeated measures design. To verify, also, I think now if I remove the ID again, yeah, the intervals also change, right? Because now that this is considered for JASP, now considered this between participant factor, but now if we add the ID, then it's within participant factor, and now so also the confidence intervals get much smaller. So this would now also mean two things. Maybe you would want to decrease the size of the means again, just roughly. Maybe also make the width of the intervals a bit smaller. I think you can do it like that, yes. And now you might also say, not always would you maybe want to have the individual trajectories show, right? Let's say you have a bunch of participants and or a bunch of observations, then maybe this is too thick of a line to show for each participant, right? This specific thickness or opacity. So we could also decrease the width now, like so. And we could also say, let's do an opacity of 10, or even just do an opacity of 0. And now we kind of also get an easier look. So when you would want to put this in your manuscript, for example, now it's easier to see the means and the confidence intervals. So again, now you have a bunch of options of what it is that you want to visualize. So far, I have shown you how to visualize data that depended on one factor, right? We had condition, and then so condition A, B, and C. But now I will show you how to visualize data sets or dependent variables that hinge on two factors. So what we have here is a data set on plant growth, and it's also simulated. And basically we have two species of plants. One is this versicolor, and then there's virginica. And basically these two species were measured at time point 1 and then also at a time point 2, a second time. And they are simulated to be affected differently by fertilizer. And to kind of get an idea of the effect, we also then measured or have this indicator. It's the width of a part of the blossom of the flowers, I think. And lastly, we again have an ID variable. So let's get a first idea of the data and how it looks like. So we again open a new plot, and we select the sepal width as a dependent variable. Then we have time as a primary factor, which now kind of splits up. And what you can already see is here there's some sort of a bimodal, unimodal distribution, right? There's only one mode. But here it turns out to be then bimodal. So there seems to be a cluster of individual flowers that kind of grew from the fertilizer, and also one that kind of decreased. So now if you have this additional information available, if you think back of the penguin species at the very beginning of the video, we now can also add this species here as a secondary factor. And then you can kind of see how the green versicolor flowers grow from the fertilizer, but the gray virginica flowers, they kind of decrease. And to visualize this even better and tidier, it now kind of also makes sense to see how the means or the group level kind of trajectories and what the effects are here. So now we will combine several things that we have done before. The first thing that we can do is select the mean again, right? And now maybe we also want to connect the means with lines. So we can already kind of see on a group level, we have the green flowers increasing and then the others decreasing. And now, unfortunately, these lines also overlap with the violence over here. So we could now also customize the orientation of these two clouds and basically mirror them, and then the lines will be in the middle. And to do that, we select again or specify the number of clouds. This time we have 4 clouds. And now we apply custom orientation. And so the first 2 clouds get oriented to the right. 2 things I now notice right away. The spacing is a bit off, so maybe let's give the plot a bit more room. Yes. Then also maybe we can make it a bit higher. And because the violence seem to reach into this y-axis, we can also decrease the height a bit, like so. That should work. Apparently it did not as good, but I have another way of fixing this, because also the last thing that we now notice, we kind of have the points still in front of these boxes, and that's not so nice, right? We want the lines to be kind of neatly connected. So what we could also now do is move these boxes with the means in front of the points. And to do that, we can simply change the nudge of the box. So for example, right now, it's kind of a positive nudge, so basically away from the axis tick in this direction, and then here it's in that direction, but of course it's mirrored. But if we now just change this to negative, let's see what happens. Then suddenly these boxes are more in the middle, or like now they're kind of central in the middle. This also means we can decrease the nudge of the violence. Right now they are closer together. Maybe that's a bit too much. Because, wait, give me 1 second. To maybe re-specify this a bit better. We could increase the nudge a bit more. And then maybe even make the plot a bit bigger still. Like so, for example. And now if you export this, maybe you would want to decrease the spacing over here, and I will later show you a trick of how to do that. But let's first consider again what we have done. Basically, we now visualize a 2x2 design and kind of can also see this interaction. Well, we did not test for this interaction now, but it looks like some like the fertilizer affects the 2 species differently. And to do that and visualize this better, we also moved the boxes in front of the point. So kind of we switched positions of the elements for a cleaner visualization. Of course, we could now also decide to show the confidence intervals. Yes, but I think now this once again considers these are not correct, right? Because this is kind of a mixed design now. We have a between factor of species and also a repeated measures design, or basically a within participant or within flower factor, so to say, which is the point in time. So then we would add ID, like so, which alters, as you can see, this also alters the size of the confidence intervals, right? And then, of course, if you now do this, you would also have to do some, choose a different angle to plot all of that. I will show you how in a second, but for now we could also get rid of that and simply just show the correct confidence intervals for this design, right? Okay, so maybe let's go back to the original, more descriptive way of showing it with the box plots instead of confidence intervals. There are 2 more things that are notable with this plot right here as is. One is, unfortunately, species, here this legend title, is not capitalized, and that's something you might want to fix for a manuscript. And then also you can see that apparently only one of the 2 species names is capitalized, whereas maybe you would want to have both in capital letters. And you can also change that in JASP, but this is not something that happens here within the module. This is something that you have to change on the data level. So we can now go to the data and edit it. So basically we double click, and then we can now go and capitalize the species column, which should work like that exactly. And then also we can change the value of this flower species to have a capitalization. And what should now basically have happened is you can see that the secondary factor got removed, because now we kind of have a new variable, and this is the previous variable just with a capitalization, so we kind of can add it again. And then you can now see how both is capitalized, right? The legend title and also the individual labels for the groups. And now there's also a second thing I wanted to point out. If we zoom in, we can find that the distances between individual points seem to be fairly equal, right? So there's always some sort of a gap here. And this kind of suggests that the data have some kind of ordinal scale, which kind of shouldn't be the case, right? Because we have some width that's probably measured in millimeters or centimeters. So this is clearly a continuous variable and not something you would have, for example, when you have 5 response options to a questionnaire, or like to a questionnaire. And so, yeah, what's up with that? Let's consider our raw data again. We will find that apparently the width is measured only to 1 decimal point, right? So all widths have 1 decimal point at most. Well, even here, right? Then it's 2.0 with which it was measured. And so this also means that we only can also visualize it like that. And this might get a bit complicated, right? Because you can see here that there are a bunch of flowers, individual flowers here that have apparently a width of 3.0, maybe centimeters or millimeters. But this is difficult to see, right? So what I will show you next is how to tackle that and basically highlight with a user visualization that kind of highlights individual trajectories, right? Because so far we considered the means and the group level, but now let's move to the individual flowers and how their trajectories change, which we can basically do with this ID variable. We now have 2 options. We can either edit this plot again that we have right here. So for example, we could again nudge the boxes so that they are not in the center, like so. But instead of doing all of that, it's also maybe a good idea in this case now to just make a new plot. So basically we could put this back to the middle, like so. And then we simply create a new plot. And so this could be maybe the mean trajectories. And these over here could be the individual trajectories. So again, we select the dependent variable, time, and species. And now, again, it makes sense to apply custom orientation with 4 clouds, like so. But this time, before we do all of that, let's again give us some space. Yes. Okay, and so now maybe a first good idea is to, because right now we're kind of really focused on the individual trajectories, right? So a good idea is to kind of also make the other elements a bit more minimal. For example, we could remove the violin outline and then maybe even decrease the shade or the opacity a bit. And we could do maybe the same for the boxes. Similarly, we could maybe decrease the box width a bit and also their padding so that they're slightly also closer together. How it works is you have this width indicator, so you can edit the width of the boxes, but then also you can alter the padding, which is then kind of subtracted from each box so that there's some more space between them. So we could have some slight padding, maybe like so. Okay, this is really not a huge difference, right? So maybe increase it. Yeah, okay. And then we make the width maybe even smaller, like so. Yes, okay, that might be okay for now. In your case, you might do further, maybe fine tune it. Now we can also decrease the nudge again of the violence. That's maybe a bit too much. Yeah, okay, and let's also decrease the height a bit. Okay. What we can do next is maybe increase the spread of our points a bit so we can see how they kind of differ. And now we have this option to jitter our points. So basically we will slightly change the actual observed values, and then we can see that this overlap due to the data format, which only has where the dependent variable only has one decimal place. If we now jitter this, well, we get some jitter, and then it's easier to see the individual points. And so also now we have this info that the points are slightly jittered, right? And then later on, when you export the plot, you then might also want to remove this caption again and simply add this jitter info to the figure node in your manuscript. So maybe like so. You just have to keep it in mind. And then lastly, we add the ID again. And now we have kind of the individual trajectories highlighted. And maybe we can make the individual lines a bit, well, maybe that's too much. Yeah, okay. And maybe we can also increase the opacity a bit. Yes, so that's starting to look like a plot that kind of highlights the individual trajectories now, right? Because now we don't have as much kind of the violence are now not as highlighted, right? We removed the outlines, decreased the opacity, we kind of made the boxes much smaller, and so now the focus is really in the middle and what's happening here, just like what we had with the means for the previous plot. And so the final takeaway, or kind of the interpretation of this specific plot would now be basically we have seen the individual trajectories. We have seen the trajectories on a group level, which should be over here, right? And now if we look at the individual trajectories, we can also see that basically each flower also follows the general group effect. So basically all green flowers also go up, and all flowers of this gray species, this Virginica species, they all decrease in width from the fertilizer. And that's something you wouldn't see if you just look at the group level, right? Now I will show you some tricks that might save you some work if you know them. So what I have here is a plot that I've created. It has specific settings, right? For example, it has a specific point size that I customized. So also the nudge of the individual elements is also something I customized. And let's now say I'm done with this plot, even though, well, it could look better, but for the sake of this tutorial, I'm now done with this plot. And I have visualized my first variable. And now let's say I want to also visualize another variable with the exact same settings. And what you can simply do is, well, you select it as another dependent variable. And then you will get a plot for the first variable up top, and then also a plot for the second variable, right? It still is kind of the same manipulation, so it's the same data structure, but we have kind of two variables that were measured, right? The first variable and also the second variable. That's one thing I wanted to show you. But let's say you are not satisfied with the specific axis range or the coloring for one of the two plots. So what you can then do instead of simply, because now these two variables use the exact same settings down here, right? So this is all identical for each plot. But let's say you would want slightly different colors for this variable and also different axis limits. Then you can also save yourself some work if you know that you can also duplicate JASP analyses, right? So right now, over here, we are visualizing the first variable. And then we can now duplicate this with this button over here. And then we kind of can visualize the second variable instead. So let's do second now. And so we remove the dependent variable and select the second dependent variable. And now what we have is what we had like before, but now we have kind of the option to slightly alter the settings. Not all of them, right? You save yourself some work because now maybe you say, okay, I want this colorblind palette. Or you would now maybe want different axis limits, right? So from here is from 0 to 50 because, well, apparently that's the range of this variable. But up here, right, maybe these are also accuracy scores, and then you would want them to range from 0 to 1, right? And so you kind of have fairly similar plots. They share settings like the distances between the elements, the width of the boxes, and so on and so forth. But you are still able, with little effort, just by duplicating it, to kind of alter the plots a bit to your liking. Now I will show you how you can use the same settings in the Raincloud Plots module to essentially visualize two data sets that also have different structures, right? In the previous example, in the previous tip, I showed you how you can use two different dependent variables within one data set and visualize them similarly or identically even. But now what I will show you is how we can also do that for entirely different data sets. So right now we have a data set and a plot. Apparently there's some manipulation. It has two levels, X and Y, and then also some dependent variable that is called FISBUS, whatever that is for now, doesn't matter. But let's say we have this plot and we're happy with it. And now for this data set 1, yeah, like I said, we're happy with it, but let's say now we also have a data set 2 that has a different structure. And so the first thing that we now do is kind of we make a backup of this very JASP file that I'm currently working in because, right, we are happy with this plot. We don't want it to change anymore. After we have done the backup, we can now also use this file, this copy of the backup, and continue to work with it. So that's the kind of the first thing that we need. And then the second thing is, of course, also the second data set, right? And let's say we already have the second data set somewhere, for example, in another JASP file. And now we want to create the plot for the second data set. So what we do here is we go to edit our data and we, first of all, remove the current data set. Maybe I cannot remove this column right now, but I should be able to in a second. And now we basically go to the other JASP file that contains the second data set, which has maybe a slightly different structure, and we copy it and we paste it into here. And then we can also remove this. And now we just have the other data set in here. This is the second data set. And you might remember from the very beginning of this tutorial, we had a condition and we also had a dependent variable. So we have to kind of rename the columns, but otherwise the data was copied correctly. And now, of course, this is not the plot for the second data set, which we are already happy with. For the first data set, I'm sorry. This is a plot for the second data set. And what happened now is we can simply use the dependent variable and the condition like so. Yes, and now we have the exact same settings for the second data set as we had for the first data set. So for example, the color palette is already selected as for the first plot. also the point size, and so on and so forth. Even though we now have apparently a primary factor that has 3 levels, and also our dependent variable is entirely different. And so, for example, this is in comparison to just creating a new file, right? Because I will show you how the default settings would now look like. Then you get this plot. And this is, of course, entirely different and does not match kind of the design and the style that we had for the first data set, right? Whereas this plot for the second data set is also matching the design that we had for the first data set. Sometimes when you create a plot, you will have some gaps between individual elements, right? So now here we have a plot that has the y-axis for the dependent variables. Then here's some space, and then we have some space over here between the two groups, and then also even some space between the second group and the legend. And I will now show you how you can basically fix that or kind of decrease these gaps between elements. And for that, we have to move to PowerPoint, but it's fairly simple over there. So what we do now is we save this image of the plot, and I will now do that, and then I will see you back in PowerPoint. Okay, so I have now opened a new fresh PowerPoint file, and let's just take the plot that I have saved as a PNG file and just drag and drop it in here. And then some windows pop up, but essentially we don't need all of that. We just can position it here nicely in the middle. Okay, so, and like I said now, the goal is to reduce these gaps. And in order to do that, we can do a nice trick. And so now we have this plot, but essentially we will now slice it up and then kind of stitch it together again, but without the gaps. So I'll give you one quick example of this. First, we copy this plot and then we paste it again, but we will kind of position it on the same kind of horizontal level as the other one, right? And what we can do now is we can move this one with the arrow keys. I can just move it to the left for now. And now I just take this plot and I can now crop it. And if I do that, I can just keep the y-axis for the dependent variable, right? Okay, so, and after I have done that, I can move this over. I think now I made a mistake because the horizontal level wasn't correct anymore, but now you can see it's still nicely aligned. And so for the next slice, we still make a backup, right? We put it over here. But this slice, we can now also crop like this. And so we basically just keep the green cloud, right? Like so. And then we can also move this over here. But now, of course, we make the gap smaller, right? So we can maybe bring this in the front, so that it's not hidden by the other slice. We can just put it here, and then we copy this. I place it over here, and now I try and crop it again, like so, and make it maybe also smaller, like this. Maybe that's the solution, right? Now I move it over with the arrow keys. And now I move on to the next one, which I again copy and paste. So you can also see that I'm now a bit winging it, but apparently it also just works, right? I crop it again. So now we just take the gray cloud over here, like this. And we can move it over with the arrow keys again, like so. And well, now maybe we can also center the group a bit more. And then for the last piece of the puzzle, we can simply move this over, but now we just want the legend, right? So we just crop everything but the legend, like this. We move it over, and suddenly we have a plot that takes up much less space than the original one. Maybe as a last thing, because we don't need this legend necessarily here, right? We could also position it somewhere else, possibly. So we can also crop this one over here. And maybe just move it like this, right? Now it doesn't take up as much space. Can even crop it further, like so, maybe. This is just an example, right? If the gray cloud was much lower, then we could also maybe put it up top over here. We could now even still do this, right? And now for the last comparison, maybe this is still a bit too squashed, but I will show you now the original plot that we had. So I just drag and drop it over here, and then we can see how it takes up much more space, right? And that's kind of not necessary, even though this might be a bit too squished. And so basically all you have now to do is kind of take this whole PowerPoint slide and export it as a PNG. And then maybe you also want to crop it afterwards so that it's not the whole white space over here. You make it smaller again. And then you have a plot, but now the gaps are kind of removed and decreased.